Okay, this example is quite simple. The example is an example of, let's say, flat rent. And this is the target variable on the test data set. Okay? And the target variable or actual prices, we have 1, 2, 3, 4, 5 cases. And these are the actual prices of those cases. This is our model's prediction. So our model, based on a set of predictors that we don't have here, has predicted these values. One way of measuring error is calculating the distance between the actual and predicted price. So let's call it error. Error is actual minus predicted. Sometimes predicted is called estimated. Okay? So actual minus predicted or actual minus estimated. It doesn't matter if we can write it also as predicted minus actual, because it's just the change of the sign, and we will see that we will deal with this problem. So for now, let's define error as this: the actual minus predicted. So let's calculate it. For the first one, the actual is 100 and the predicted is 50, therefore the error here is 50. For the second one, it is 200 minus 250 is equal to minus 50. For the third one, it is 120 minus 170 is equal to minus 50. For the fourth one is 80 minus 30 is equal to minus 50. For the fifth one is 90 minus 90 is equal to 0. So these are errors. Okay, these are our errors. 50 minus 50 minus 50 minus 50 and this one is plus 50 and a 0. Okay, we might have other values. Let's say that for this one, the value was 300 and we predicted as 320. In that case, 300 minus 320 would be minus 20. And so on, so forth. So, but for our example, just 5 cases are enough. Now, you might say that, okay, for an aggregate metric, for a metric over all cases of the testing data set, it would be good if we sum all the errors. So it would be a sigma of all errors would be 50 minus 50 minus 50 plus 50 plus 0 equal to 0. And do you think that it's correct that the error of our model in this data set is 0? This statement is not compatible, is not following the reality of our model and our modeling in general. Because error equal to 0 means the model is perfect. But actually we can see that our model is overestimating here. Our model is underestimating here. Our model is underestimating here because its prediction is lower than the actual value. Our model is overestimating here. Our model is again 50 units of price far from the actual value for the third prediction, 50 in the fourth one, and only in the fifth one our model is exactly predicting the price as the actual value. So just sum them up is not a good idea, because the errors, these minus and plus signs, they cancel out each other. and we do not want them to cancel out each other. We want them to show the deviation from the actual prices. We want them to show the actual performance rather than canceling out each other and showing some unrealistic performance. So let's go for a very simple operation to solve this problem. And that operation is just calculating the absolute of error. So the absolute of 50 is 50, the absolute of minus 50 is 50, the absolute of minus 50 is 50, the absolute of plus 50 is 50, and then the absolute of 0 is 0. Okay, so we have omitted all the negative signs, and now if we sum them, the summation would be 200. Is it a good metric? Well, it is better than the previous one, but not good in the meaning that if we have new cases, that 300 and 320, let's say a 500 and 450, and so on and so forth. So because all the values are absolute, either they are positive or 0, this sum of the absolute errors would increase regardless of the performance of our model. So would increase by the number of cases in the testing set. So it wouldn't show the actual performance for every single prediction. It's an aggregate thing, and it increases, this value increases by growth of the number of the cases in the target variable. So let's solve this problem. And how to solve it? Well, actually we can divide it by the number of cases in testing. Okay, or in general, number of predictions. So in that case, we divide 200 by 5 in our example, which would be 40. So this 40, it is called the mean absolute error. Okay, so we defined error as the distance between the actual and predicted values. And we said that if we aggregate all the errors, they will cancel out each other. So we add this absolute operation to remove the negative signs and not let the summation to cancel out the negative and positive signs. And then in order to standardize our value, make it independent to the size of the data set, we use the average or the mean. So mean absolute error is telling us that how much each prediction is far from the actual value on average. Let me write it. How much on average every single prediction is far from the actual target values. So this is the definition of mean absolute error. And mean absolute error is a very simple and very useful metric to measure the performance of a regression problem.